Hello people, I'm back. Hope you're feeling good today and you're right back on track. Today we're gonna talk about deck of playing cards and how to get some probability and percentage for them. Yes sir, alright. I'm back people, I'm back. So if you know that crazy song I'm singing to in the background, you can send me that later. Alright. Woo! That's a good one. That there's a country classic. Alright, so as you can see, I've got some kings laid out here. Since I'm the king of mathematics, I figured I'd start out with that. So I just want to talk to you because I've noticed that you young people, you don't do a whole lot of work with a deck of cards. Evidently mom and dad don't play cards with you, or granny and grandpa don't play cards with you. So maybe some of you do, but a lot of you don't. So these right here are diamonds. These are clubs. These are spades. And these right here are hearts. So you got diamonds, clubs, spades, and hearts. So those are the four suits. So we're going to start out with that. Okay. Number one, four suits. And the four suits are diamonds, hearts. I'll do them by color. Diamonds and hearts are both red. So you got red diamonds. You got red hearts. We'll put them together. Then you got the two black suits, okay? We got the two black ones, those are clubs and spades, all right? So we got black suits are clubs, and another black suit is spades. One of my favorite games, if you ever, I know some people like to play hearts. I like to play spades. It's about the same either way, I think, from what I've heard. So if you're a spade player or a heart player, you know what I'm talking about. All right, so in the okay, 52 cards. So in the 52 cards, we are not talking about any jokers, okay? We're just talking about the normal 52 cards. There are 13 diamonds, 13 hearts, 13 clubs, and 13 spades. There are 13 of each one of them. So if you go from ace to king, okay? Ace to king. Alright, there's 13 diamonds, 13 hearts, 13 clubs, 13 spades. 52 total, okay? 13 plus 13, 26. 26 plus 26, 52. Alright, so there you go. Now, I want to talk to you about some other questions you might see, okay? The kings are known as face cards because they've got a face on them. You see them kings got faces? Okay, them kings got faces. Them kings got faces, all right? So they got face cards. So kings are considered face cards. Queens also considered face cards. Okay, why are that? Well, she's got a face, and she's got a face, and she's got a face, and she's got a face. All right, so you also got queens that are face cards. So let's put these down here for number 3. Face cards. All right, so you got 4 kings and 4 queens. Hey, do y'all know what the other one is that's got faces on it besides kings and queens? That'd be these jokers right here. So those are the jacks, okay? Now, there are supposed to be in this deck, okay, yeah, there they are. All right, so there are 2 jacks that have both eyes showing, okay? And there are 2 jacks that are known as one-eyed jacks, okay? So you can only see half their face. So that jack's got one eye. That jack's got one eye. So you got a couple of one-eyed jacks and a couple of two-eyed jacks for a grand total of 4 jacks. So grand total, how many face cards are there? Well, 4 plus 4 plus 4, or 4 times 3, is 12. So there are 12 total face cards. Let me scoop that up just a hair so I can fit it all in there. Alright, so if you go through here, you got 4 kings, 4 queens, 4 jacks, grand total of 12 face cards. Okay? Now I'm sure y'all are familiar with the aces. Okay? The aces don't have faces on them. Okay? They're just plain cards. So we got ace. Here's our ace of diamonds, ace of hearts, ace of clubs, ace of spades. So there's 4 of them. Okay? Now, aces. 4 of those. just like all the rest of the cards. Okay, all the rest of the cards are just 4 of them. There's 4 2s, there's 4 5s, there's 4 6s, 4 8s, 4 9s, 4 10s, whatever. Okay, there's 4 of the rest of them. So just real fast, I'm going to run through and do some probability on some of this deck of playing card stuff. And then remember, a probability is a fraction. So probability is a simplified fraction. Probability is a simplified fraction. Now you can take that fraction, and we're going to take the fraction and we're going to turn it into a percentage, but a percentage is not a probability. A probability is a simplified fraction which you can then turn into a percentage. Alright, so let's say this is our first question about the cards. Let's say, what is the probability of a king? Okay, so how many kings are in the deck? Well, if you look up here, there are 4 kings. How many cards are in the deck? 52. Okay, so there is a theoretical probability of getting 4 kings out of the deck of 52 cards. Can I simplify that? Well, I sure can. Oh, you gamblers out there know you can divide them by 4. 4 divided by 4 give me 1. 52 divided by 4 is the number you might have to think on a second. So how many times will 4 go into 52? See, that's 4. One time, that's got 12 left over. 4 goes to 12. Oh, that's 13. All right, so 4 over 52 simplifies or reduces down to 1/13. Okay, so that means you have theoretically a 1 out of 13 chance of pulling a king out of the deck. Okay, if you just had the deck fanned out in front of you, okay, you know, you just kind of had them all fanned out like this, but you couldn't see them, and you just had them turn like that, okay, and you fan the deck out in front of you. That means you got a 1 out of 13 chance of pulling a king anytime you do it. Now, we're going to take that probability of 1/13, and now we're going to turn that into a percentage. We are going to do that by setting up our little proportion over here. So I'm going to do 1/13 equals x over 100. Okay, this is the work that you do to change it to a percentage. You set up a little percent proportion. Percent proportion. Alright, so I would of course say cross multiply there. That's going to give me 13 times x, which is 13x. I'm going to cross multiply here. 1 times 100 is 100. So now I've got 13x equals 100. Then I would have to divide by 13 on both sides. 13 divided by 13, of course, is 1. Now I'm going to get my calculator out here, and you can use your phone, or you know, you've got these on your computer if you want to. These nice little TI-84s. Let me slide over here so you don't have so much glare. So that would be 100 divided by 18. I'll go back. That's 13. We're going to round that to the nearest tenths place. Okay. So since there's a 9 right there, we're going to round that to a 7.7%. Don't forget to put your percent sign on the end of there. So that means at any time that all 52 cards are on the deck, okay, all 52 of them are in there, no jokers, just the regular normal playing cards, you got a 7.7% chance of drawing out a king. 7.7%. This is the probability. This is the percentage. This is the probability. Okay? Theoretically, you got a 1 out of 13 chance of pulling out a king, which translates into 7.7%. So if it's asking for a fraction that you can simplify, that's the probability. 1/13. Okay, now let's get a little riddle in here today, okay? So here is your riddle for today. If you've watched it up to this point, you've been watching me about 9-10 minutes, so here is your riddle of the day. I have 13 hearts, but never breathe. What am I? I have 13 hearts but never breathe. What am I? So if you'd like to send me your answer to that question today, feel free. You know the drill. Send me a little email and tell me what that might be. I have 13 hearts but never breathe. All right, we'll see you next time. So there you go, people. All right, let's do one more deck of playing cards questions, and I think I've probably about enough. So let's do face cards. What is the probability of getting a face card out of the deck? All right, again, remember, all of the face cards are these right here. The 4 jacks, there are 4 queens, and of course there are 4 kings. So all together, 4 and 4 and 4, how many face cards are there? That would be 12 out of 52. Okay? Now, will 12 out of 52, will that probability simplify? Of course it will, okay? Because you can divide both of those by 4. Okay? So divide that by 4, divide that by 4. 12 divided by 4, of course, is 3. 52 divided by 4, of course, we did that in the last problem up there. That is 13. So the probability of drawing a face card at any time out of the deck is 3/13. That means if you flip them over, okay, and they're all mixed up in there, and you draw one, there's a 3 out of 13 chance of drawing a face card. All right, now let's do this again. We're going to set up our percent proportion over here. Percent proportion. All right, gamblers, here we go. We got 3 out of 13 equals x over a hundo. 13 times x, 13x. 3 times 100 is 300. So at the moment, I've got 13x equals 300. What's my next step? Hopefully you're saying I got to divide both sides by 13. 13 divided by 13 is 1, Mr. Reid. Now let's see what 300 divided by 13 gives us. Are you ready? That's a lot. Let me turn it that way. If I do it that way, you don't have as much glare. Let's see. 300 divided by 13, and that looks like that would be 27 point. Since there's a 7 right there, that means I got to round it up, so it'd be 23.1%. 23.1%. 23.1%. Make sure you put the percent sign on the end of it, just like that. All right. So hopefully that gives you a little more knowledge about what you're doing here. All right, before you get up and count your money, all right, make sure you know that the difference between the probability and the percentage is a probability is the fraction answer. The probability is a simplified fraction. Then you set up your little proportion to get your percentage. All right, if you know what the riddle answer is, feel free to email me that. Make sure you send me a picture of your work. Send me a picture of your work. If you don't send a picture, you'll get a 50. Yeah, it worked out pretty good, didn't it? All right, we'll talk to you later. Adios, partner. Peace out.